A very warm welcome to the fourth issue of The Missing Link. We are all aware that the Earth is observing record-breaking temperatures every season. But are you actually aware about the factors contributing to this change? Are you aware that Mars has a role to play in this warming temperature? Are you aware that oceans and trees on Earth are actually contributing to global warming on Earth right now? We'll be understanding all of these factors and many more in the fourth issue of The Missing Link, where we shall be analyzing the warming atmosphere. Beginning with the first aspect, this year a very important research paper has been published. This research paper has finally established that what is the role of Mars in deciding climate on Earth. It has been established that the orbits of Mars and Earth, they tend to resonate or they tend to align after every 2.4 million years. So after every 24 lakh years, the orbits of Earth and Mars align. When this thing actually takes place, it has an impact on the Earth's orbit as well. You all must have heard this thing that the Earth revolves around the Sun in an elliptical path. Now this path is not always elliptical. As of today, it is almost a perfect sphere. But for the past few thousand years, for the past few, you can say almost 1 lakh year, it has been elliptical. Now it is very important to understand the impact of these large scale cycles in deciding the climate the Earth is observing as of today. Like I established at the onset of the video, because of that research paper, these cycles become important. Therefore, a question can be asked on these cycles in the pre-exam itself. Now, when the Earth orbits around the Sun in an elliptical path, naturally, one position is closer to the Sun. We call this closer position as perihelion. The opposite position on the orbit is the farthest position. It is called aphelion. As of today, when we observe summers in the northern hemisphere, why? Because the northern hemisphere is inclined towards the Sun and this position is observed during aphelion. Therefore, the summers that the northern hemisphere has been observing for the past few thousand years have been moderate. Why do I call it moderate? Because if the northern hemisphere would have been facing the Sun at perihelion, it would have been receiving more heat. But since as of today, the northern hemisphere is inclined towards the Sun at aphelion, the summers are actually moderate. But what about Antarctica? Antarctica has been observing extremely cold winters for the past 1,000 years. Simultaneously, what has Antarctica also been observing? When the Earth orbits around the Sun and reaches the opposite position called perihelion, for the past few thousand years, what has Antarctica been observing? When the Earth is at perihelion, the southern hemisphere observes summers. And for the past few thousand years, Antarctica has been observing warmer than normal summers as well. This is one factor which is actually contributing to heat in the southern hemisphere and leading to melting of ice in Antarctica. As of today, the Earth's orbit is gradually becoming circular, and as of today, it is the most circular in the past few million years. What is going to be the impact of this almost circular orbit right now? Winters on Earth are set to be milder. Therefore, winters on Earth are set to be milder because of this cycle of eccentricity. But this cycle alone will not decide what takes place on Earth. But because of this cycle, what is being observed? That warming in Antarctica has taken place, and from now, winters across the Earth are going to be milder in both hemispheres. When we talk about the next cycle, it is called precession. All of you must have played with a spinning top, lattu. When you move a spinning top, it moves perfectly straight. But as it starts to slow down, it starts to wobble. Even the Earth wobbles like a slowing spinning top. This is a 26,000-year-old cycle. 26,000-year cycle. Now, what do we mean by this? Let me give you an illustration. What do we mean by this cycle of precession? Remember, we just discussed which hemisphere is inclined towards the sun at which part of the orbit. What does precession change? After, you can say, 13,000 years. It is a cycle of 26,000 years. So after 13,000 years, the southern hemisphere will be facing the sun during aphelion. And after 13,000 years, in the same orbit, the northern hemisphere is going to receive more heat because it will be facing the sun at perihelion. So the precession cycle itself decides which hemisphere receives more heat in the short term. What is the present position? Present position is that the northern hemisphere is inclined towards the sun in the aphelion position. This is going to change in the next, you can say, few thousand years. So because of precession, the northern hemisphere is soon going to receive more heat on Earth. Why is this important? Because the northern hemisphere contains more land mass. We are all aware that land is liberal, water is conservative. When this position will take place, all the land masses will gain more heat. They will heat up even faster. They will contribute to that heat into the atmosphere even more. So due to precession, the northern hemisphere is set to get warmer in the coming few years. Talking about the third important cycle in this series of cycles called the Milankovitch cycles, it is called obliquity. It is a 41,000-year cycle. Now, what do you mean by obliquity? The Earth is inclined relative to its, you can say, vertical position, right? We talk about the inclination of the Earth's axis. Generally, we give a figure 23.5 degrees. But are you aware it fluctuates between 24.5 to 22.1? Right now, it is 23.5 and declining. The Earth's inclination on its axis is actually decreasing. Now, it is very important to understand what change it is going to have on the Earth as a whole. Now, imagine the sun is somewhere over here, and right now this is the 23.5 inclination that we observe. It is very significant to observe how obliquity decides which area will receive heat on Earth. Now, suppose the sun is somewhere over here. The sun is vertically overhead the Tropic of Cancer at this position. Therefore, the Tropic of Cancer will be heated a lot. The Earth is orbiting around the sun, orbiting around the sun. It reaches the other extreme. Now, the Tropic of Capricorn is receiving vertical sun's rays. So, in this present position, the area where the vertical sun's rays are confined are the tropical areas. Tropic of Cancer, Tropic of Capricorn, 23.5 degrees north and south. But what will happen if you reduce the inclination? Once you reduce the inclination, the sun will be directly overhead at latitudes closer to the equator at both positions. Therefore, the area where heat will be confined on Earth will be closer to the equator. Why is that important? Because when this thing takes place in the coming few years, more heat will be confined in latitudes closer to the equator. Why is that very important? Because in this belt, the most important part that we find is the Pacific Ocean. We are all aware that water is conservative. It takes a lot of time to heat up. It takes a lot of time to cool down. Right now, everything is favoring for more heat to be confined in the equatorial areas. And all of these waters are gaining heat. Because of all of this gaining heat in the water, because of this orbital resonance with Mars, something very unique, or not unique, something very important is going on Earth right now. The heat in the entire Earth is circulated not just in the atmosphere, but in the entire ocean water as well. Warmer waters are transported to the polar areas. All this water, upon cooling down at the polar area, it freezes. All of that cold, then salt water, then sinks, and it creates a circulation of water that is called the thermohaline circulation. This thermohaline circulation is very important to actually moderate climate on Earth. Good circulating water is going to have, you can say, better climatic conditions. Let me tell you what is the implication that I'm talking about over here. Right now, because of this research that has been recently established, because of the orbital resonance of Mars, because of the warming waters being observed across the Earth, this circulation of water is actually weakening. I have talked about the weakening thermohaline in a separate video as well. You can search weakening AMOC and you will find a detailed explanation on that. But right now I'm focusing on the warming atmosphere. What impact does this have? Slower circulating water will remain under the sun for longer. The thermohaline circulation is weakening, meaning thereby the ocean water is circulating a little slower. Slower circulating water will remain within the tropical areas for a longer time. We have established right now that tropical areas are steadily gaining more heat. All of this heat is going to be absorbed by all of this water. Now, what is going to be observed in this entire area? Let's come to this concept of why cold drinks are called cold drinks. When you talk about cold drinks, they are basically aerated, they are carbonated. Cold water has better gas retention properties. But when you heat up water, molecules start to vibrate, the distances between molecules increase, and all the trapped gases, they start escaping. Right now, all of the waters across the Earth are heating a lot, and the molecular spaces between them are increasing and they are releasing gases. But the very important factor is which gas are they actually releasing? In the mid 1800s, Europe observed the Industrial Revolution and they released a lot of carbon dioxide during that time. When carbon dioxide is released into the atmosphere, it mixes with rainwater and it creates something called carbonic acid, which is a weak acid. That is called ocean acidification. All of that carbonic acid, it entered the North Atlantic where it sank along with the thermohaline. And once the water sinks in the thermohaline circulation, it may take 100-200 years to resurface. All that fossil carbon rich water is now resurfacing on Earth, and right now on Earth the surface waters are the warmest ever observed on Earth. All of that fossil carbon rich water, upon heating, slowly the intermolecular spaces are increasing and they are releasing all that trapped carbon dioxide into the air. So the oceans on Earth right now are actually leading to an addition of carbon dioxide in the air. What is carbon dioxide? It is a greenhouse gas. More greenhouse gas in the air, it is going to trap more heat. Warmer atmosphere is going to observe expansion. Air molecules are going to vibrate more. Therefore, it will have more intermolecular spaces. Warm air and warm water will lead to more evaporation. More evaporation will add water vapor in the air. Water vapor is also a greenhouse gas. Therefore, the atmosphere is going to absorb more heat. The warmer the atmosphere gets, the more the evaporation potential, and this cycle continues. This is called a positive feedback. Warming atmosphere is going to promote more evaporation. More evaporation will add more water vapor. Water vapor is a greenhouse gas. Water is not just adding water vapor but carbon dioxide as well, and this cycle aggravates, keep on adding heat into the atmosphere. It is not just the oceans which are adding this thing. Are you all aware that trees, vegetation, they undergo a process called photosynthesis? What is photosynthesis? They use sunlight and water and produce energy for themselves and release oxygen as a byproduct. Right now, the concentration of carbon dioxide in the atmosphere is the maximum ever observed. Suppose you are thirsty and I give you a glass of water to drink, you'll enjoy it. I offer you another glass of water, you'll enjoy it. But what will happen when I offer you third, fourth, fifth glass of water? You will get saturated, you will not be able to drink that water. The same thing is being observed in the tropical forests as of today. Another very important research has been published this year, which has established that trees in the tropical areas are so stressed right now because of this over presence of carbon dioxide that they are actually releasing this carbon dioxide back. Trees in the tropical areas are undergoing photorespiration. They are actually releasing carbon dioxide back into the atmosphere. So yes, tropical trees and warm water are both adding carbon dioxide into the atmosphere. What is carbon dioxide? A greenhouse gas. We are all aware about greenhouse gases, but do we actually talk about these things? These are a major source of carbon dioxide emissions. I have not even come to the anthropogenic part as of now. I'm just beginning with this discussion. Right? So this also aggravates the positive feedback. More carbon dioxide in the atmosphere is actually going to increase the temperature, which will allow more evaporation of water. In this debate, let's add a few more factors. Warming conditions on Earth are actually exposing the polar areas as well. In polar areas, we observe something called, or not, you can say polar areas in the boreal latitudes. Boreal latitudes means just south of the Arctic Circle, because no landmass is present in these latitudes in the southern hemisphere. So in the boreal latitudes, the temperatures are so cold that the groundwater remains almost permanently frozen throughout the year. This frozen groundwater condition is called permafrost. Because of this warming atmosphere, the permafrost layer is melting rapidly. Every year it melts more deeper than it normally does. Now, normally under permafrost conditions, the condition is very cold and all of the dead plant and animal matter trapped within the groundwater, trapped within the soil, it is not able to interact with the atmospheric oxygen. So under permafrost conditions, all of this organic matter is decomposing in the absence of oxygen. Decomposition of organic matter in the absence of oxygen releases methane. All of that methane is trapped within the permafrost, but the permafrost has started to melt rapidly. Melting permafrost has started oozing methane from this entire belt into the atmosphere. Entire melting permafrost, all the boreal latitudes just south of the Arctic Circle are leaking methane. Methane is 80 times more harmful than carbon dioxide in the short term. What do you mean by short term? 20 years. So if you consider the impact of carbon dioxide and methane for 20 years, methane is 80 times more deadly, which is why the Arctic is warming 4 times faster than the rest of the world. Methane is going to trap more heat. The more heat methane traps, the faster the ice will melt. The faster the ice melts, the more methane will be released. The more methane will be released, the more warm the atmosphere will get, the faster the ice will melt. And hold on, it is not just this methane. White surfaces reflect sunlight. That is called albedo. Lesser ice will trap more heat. So now you can add all of these factors to the warming atmosphere as well, as to how all of this leaking carbon dioxide, leaking methane is actually contributing to global warming. I'm not done with all the factors. Are you all aware that when we reach crude oil, the first thing that we need to extract is natural gas? Always in petroleum reserves which are found in anticlines which have trapped sedimentary rocks. I'm not going to go into that detail. But the thing is, whenever you find oil reserves, over oil reserves you find natural gas reserves, which is why you will always find this thing, that wherever oil drilling is taking place, you always have a flame where some leaking methane is set on fire. This year, a third very important research has been published, and it states that earlier it was thought that this leaking methane could be burnt and the amount of methane added into the atmosphere can be reduced. But the thing is, even if this research established that even if you're burning leaking methane, still a lot more methane gets added into the atmosphere. So existing oil drilling projects are contributing to more methane emissions into the atmosphere than previously thought. If that was not enough, suspended and discarded oil drilling platforms, which are not burning this leaking methane anymore, they are also leaking methane in large quantities. You heard me right. Suspended oil drilling platforms which are not active anymore, they have not plugged these, you can say, outlets properly, and all of them are also leaking methane. I have added all the actual facts related to all of this in the document attached to this series. But anyway, what is this? Another source of methane. What is methane? Another greenhouse gas. Add it to the positive feedback. I have not even included the greenhouse gas emissions from pollutants, etc., that we are used to talk about. Take into account all of these factors when you talk about the warming atmosphere, and it brings us to the bottom line. What decides the carrying capacity of air? What do you mean by carrying capacity? How much moisture the air can absorb. Warmer air is going to absorb more moisture, and all the factors that we have just discussed. What do they prove? That the air is warmest on earth observed right now. Warmer air is going to absorb more moisture unless and until that body of air reaches saturation. What is saturation? Now suppose I have a glass. It can accommodate around 200 ml of water. When I fill this with 200 ml of water, we call that saturation, right? Air on earth right now in the atmosphere, it is so warm that it is gradually increasing its carrying capacity. It can absorb more and more moisture. Now, unless that air saturates, unless the glass fills, it cannot overflow. Until and unless saturation takes place, rain cannot take place, which is why right now on earth, a phenomena is being observed called atmospheric river. There is so much moisture in the air. It is, you can say, for example, just one tiny atmospheric river can contain more than 5 times the volume of the river Amazon in it. Just one tiny atmospheric river. Now, all of this brings us to a conclusion. Two things are observed on earth right now because of atmospheric rivers. Either it will not rain at all. Why will it not rain at all? Because the air is not cooling sufficiently. It is not saturating. Or when it saturates, it is going to cause flooding. So either it will not rain on earth right now, or it is going to cause immense flooding. That is the main impact of global warming as well. It is leading to frequent flooding. It is leading to many other factors as well. But in this issue, my focus was to enlighten you on the actual factors which are contributing to the warming atmosphere. As always, I have included a lot of, you can say, this entire debate and lot more in the document attached to this issue. Join me further for further editions. Thank you so much.